So in this exam-style question, we're going to look at alpha decay. So alpha decay is a process by which an unstable isotope of an element may decay. They'd like us to state what is meant by isotopes. So here, there's a couple of key phrases they're looking for, so we're just going to write down the answer and just identify what those are, and what we could have also said instead. So what we see is an acceptable answer would have been that isotopes of an element have the same number of protons, but a different number of neutrons. The key phrase there was that you said, well, obviously you reference isotopes, but you said they had the same number of protons, but a different number of neutrons. The key thing is that there's a few different phrases you could have used there. You could have said, for instance, the same atomic number. And for different number of neutrons, you could have said that it's different mass number or different nucleon number. All of these things express the same point, that the proton number or atomic number determines what element you are, and then the neutron number, or say your nucleon number, because remember all that is just adding your number of neutrons to the number of protons you've got, your nucleon number or your mass number, that's what determines the particular isotope of element that you are. So different phrases expressing the same thing would have worked, but you had to get across this main point. The next thing they'd like us to do is just to calculate this equation for alpha decay. Now we've done these before, but we see this as a slightly different setup. The first thing is that we don't really need to care about what these are. This is polonium, this is lead, this is an alpha particle, we do know what that is. But we're much more interested in these numbers here. So we've left these purple lines for us to basically write our answers on, so we're just going to go through and do that. The first thing is to realise that without a periodic table, we don't know what these numbers are. We certainly don't want to know what this one is, because we don't know what isotope of lead we're dealing with. Remember, this is what determines what isotope we have. But we certainly don't know what the atomic number of polonium is without looking at a periodic table, and we don't have one of those on hand right now. What we can do is that they've left us this to fill out, and that's kind of the key thing. What we need to realise is that we know what an alpha particle has. We know that it's got a nucleon number of 4 and an atomic number of 2. So once we filled that out, we realise we can do the rest of this equation. We know that this polonium must have basically started with 2 more protons than it ended with, because it's lost 2 to this alpha particle when it emitted that. And lead has an atomic number of 82, so polonium must have an atomic number of 84. And that successfully balances this bottom line of the equation. We see that 84 is just equal to 82 plus 2. The next thing we need to do is work out the top line. So we see that we started with this 210 as our nucleon number, and then we lost 4 to this alpha particle, so we know that here we must have, just going back to this equation, we must have that it's A minus 4 on the top, right? We start with A, then we end with A minus 4 for our daughter isotope.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.